Hi, we're up to a thing called sums and differences with the trig ratios, and at the end of the day you're likely going to have access to a cheat sheet, so you don't have to know the proof, but at 11 methods level you should know where these formulas are coming from. So what I've got is all these things here. For me to prove what we're going to be proving, you need to know all these things. So the distance between 2 points is from coordinate geometry. That's the difference in the x's squared plus the difference in the y squared, so that's the distance between 2 points. The new thing that we've learnt this year, the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. These next two you should be familiar with. It's to do with the quadrant. So like an angle in the positive for sine is the same as the negative. So like if you looked at an angle in the first for sine and an angle in the negative first for sine, the differences is one's a plus and one's a minus. So if you're going to make them equal, you just have to change the sign. So like for instance, sine of 30 equals minus sine of minus 30. The next one is straightforward, same application. If you've got cos of theta, it's the same as cos of minus theta because cos is positive in the first and the fourth quadrants. You can check that on your calculator. Cos 30 equals cos of minus 30. They don't change signs. The next one, again, you should have done maybe in junior school. But these are the complementaries. Like for instance, 40 and 50 are the complement of each other, and sine of 40 is the same as cos of 50, or cos of 20 equals sine of 70. So that's just the complement idea. They're both angles in a right angle triangle, and they switch over. The other one that we've learnt this year is sine squared plus cos squared equals 1, and maybe you've learnt this year tan theta equals sine over cos. So all of these things we need to prove the formulas. And again, I have to show you where they come from, but at the end of the day, there's a summary at the end, which is all you need to know. Okay, so the first part is I'm just defining two angles. The angle A is the first up to the first ray, and the angle B is across to the second one. So the angle B goes all the way across. So the difference between the two angles is B minus A. This coordinate over here is cos A sine A. You put the don't forget that it's x, y, so across the bottom is x, which is cos. And over here at the top, it's cos b, sine b. So if I redrew the triangle, I'd have this little triangle with the vertical distance being sine b minus sine a, and the horizontal distance being cos b minus cos a. And if I redrew, not with the right angle triangle, but just any old triangle, I've got a unit circle, so I've got 1 for the radiuses, I've got the angle as b minus a, and the distance between those 2 points is called d. So copy that down if you want to. So from the triangle which had b minus a in the angle, and using the cosine rule, okay, so the cosine rule, okay, so you've got distance squared, a squared equals b squared plus c squared minus 2bc cos a. So the distance squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times cos b minus a, and then 1 squared plus 1 squared is 2, and then this 2 times 1 times 2 is minus 2. And then from the right angle triangle, using Pythagoras, so this is from Pythagoras or the distance formula, it doesn't matter. Okay, so I've got distance squared equals those two things squared, and then I expand them out. So this is like a minus b squared is a squared minus 2ab plus b squared. And again, I've got a minus b squared, a different a minus b. So I've got a squared minus 2ab plus b squared. And I've lined them up because these two things here add up to 1. And those two things there add up to 1. And then I factorise the middle two terms and take the minus 2 out. Okay, so all I've done is I've expanded the brackets, and then I've grouped like things, and I've actually used one of the identities. So I've got a d squared here, and I've got a d squared here, and it's the same distance, so it has to be the same distance squared. So what I'm doing here is I'm making them equal to each other. So this is one of the distance squared, and this is the other distance squared. Okay, just putting the two together, and you should see, like, it's not hard to see, that 2 and that minus 2 will cancel out with that 2 and that minus 2. So you're left with cos b minus a equals cos b cos a plus sine b sine a. And just because we like alphabetical order, I'm just switching the order. So cos a minus b is cos a cos b with a plus sign, sine A, sine B. So that's the first of the formulas. It's called the difference formula, okay? It's called a difference formula because there's a subtraction in between, okay? So on the next page, let's see what happens. So I've transferred the formula up to the top, and this time I'm going to replace this number here, I'm going to replace that B with a negative B, a negative angle. So it's just taking B to minus B. Okay, so there's a minus sign in between, so that minus sign is the first minus sign, and B is minus B. Okay, so where the B is, there and there, I've just replaced it with a minus B, okay? And then here, I've got minus a minus, which is a plus, so now I've got a sum, okay? Before I had a difference, now I've got a sum. And from earlier, cos of minus B is the same as cos of B, and sine of minus B is minus sine B. So now I've got a different formula. So what we notice is they both start with the same cos, and they finish with a sine, two sines. But when you have a plus, you have a minus in between. But when you had a minus, you had a plus in between. So again, at the end of the day, you're going to most likely have access to these formulas in your cheat sheet, but you need to know that they have come from mathematics. Okay, so let's have a look at the sine ones next. Okay, so to do this one, you have to remember that sine and cos are related by the complement. So sine theta is cos of 90 minus theta. Okay, so where the theta is, okay, there, I'm just going to put A plus B. Okay, so there's the theta, so I'm just going to replace it with A plus B. So sine theta is cos 90 minus theta. Instead of having theta as a single term, I'm going to call it A plus B. So where theta is, I'm just going to call it A plus B. Okay, so the next step is a minus and a positive is a minus and a positive is a minus. And then what I'm going to do is I'm just going to group those two together and just put a bracket around it. Okay. So I've got a sign with a sum, okay, a sum, because I've got a plus sign. Now, using what we've just learnt in the previous slide, okay, so this is like a new letter, like A. Look, it's a new letter, X, whatever you like. So we've just learnt when you have a minus, okay, we've got cos with a difference, so it's going to end up with a plus in between. So we've got cos of this number, that number there, cos B, the second letter, plus sine of that same number, sine B. And then this number here is the same as sine A because we've got the complement. Cos B is cos B. This here is the complement. Okay, so that turns into cos A, sine B. And so you have a nice little pattern. So you've got sine A plus B is sine A cos B plus cos A sine B. And this time the sine, we've got a sum, and this time the sum matches, whereas in the cos it flips over. Okay, so that's our first of our formulas, which is called the sum. Okay, and then let's have a look at the next slide when you're ready.